When we look at the equation for a pressure distribution in a liquid, we can develop a certain form of technology, or it has been developed, that is really quite useful, and that is the barometer, the ability to measure atmospheric pressure. So if we recall back, the equation for hydrostatic pressure distribution in a liquid is as follows. And with the barometer, if you know pressure at one point, you can determine it at the other. So let's take a look at the principle behind the Mercury Barometer. So typically what we have is we'll have a container with mercury in it, and usually what they'll do, they'll put a glass tube in there and they'll invert it. So we'd have mercury like that. And so the density of mercury, rho Hg, and here we have atmospheric pressure acting on the outside, and what they would do is they would form a vacuum, and so the pressure here would be roughly equal to 0. And then what they would do, they would measure the height of this column, and that would be height h, and this position here is z1 equals h. So, and the position down here is z2 equals 0. So the operation of a mercury thermometer or barometer uses this equation here, and the way that it operates is we know z1 equals h, and at that location, pressure 1 is equal to 0 because we said that there was a vacuum formed at the top of this tube. And at Z2 equals 0, we know that the pressure there is equal to the atmospheric pressure. And remember, with a barometer, this is what we're after. We want to be able to measure the atmospheric pressure. So that's the purpose of the barometer. So using the equation for hydrostatic pressure distribution in a liquid, what we can write out is we can write P atmosphere, which is P2, minus P1 is 0, is equal to minus rho, and we're talking the density of mercury times the gravity constant, times at would be Z2, 0 minus H. So what we end up with is P atmosphere equals the density of mercury times the gravitational constant times H. And that's a relatively simple equation that then enables us to determine the atmospheric pressure. So what you do, you measure the height of the column in order to get atmospheric pressure. So that is the way that the mercury barometer operates. Now, taking a look for typical values, so let's say we have P atmosphere equals 101.325 pascals, and that would be at sea level. And knowing the density of mercury at room temperature, 13,580 kilograms per meter cubed, we can go to our equation, P atmosphere equals rho Hg/gh. We know P atmosphere, there we know the density, we know the gravitational constant, so that can enable us to determine how high that column should be. And when we do that, we get 760.58 millimeters of mercury for 1 atmosphere pressure. So quite often you'll hear people refer to atmospheric pressure as being 101.325 pascals. You'll also hear 14.7 psia, but you might also hear them refer to it as being 760 millimeters Hg, and that's where that is coming from. And we just saw it with the equation, and that would be the way that you could determine that. So what we're going to do now, the barometer is a very important scientific tool and instrument, and we use it quite often. What we're going to do, we're going to take a look at the current form of barometer, and then we'll look historically at the development of the barometer. So here we have a video clip of a barometer outside of a laboratory. It's actually in a wind tunnel. And there's a little screw at the bottom. You would adjust the pin to be right at the level of the mercury, and then you'd read it on the scale. So there's the scale, and that would tell you the pressure. That is the current form of barometer that we use. But now let's look at the historical development of the barometer. So if you ever have an opportunity to go to Paris, I would highly recommend you go to the Museum Arts et Métiers. They have a collection of scientific instruments that is very, very impressive, and this is the cabinet full of barometers. And so what we're going to do, we're going to look at a few barometers. This is a siphon barometer from the 19th century. This is a top of a double barometer by Huygens from 1780, and there you can see the bottom of the double barometer by Huygens. This is a compact or shortened barometer that was developed in 1768. This is a spiral barometer from 1838. This is an alcohol thermometer. Remember, temperature is another measurement that we always want to make. And this is a combination by Borden and Perica that they had both temperature and pressure, and with that they could forecast weather. So those are some early barometers that were developed between 1750 and 1850. Barometers and thermometers, the ability to measure both pressure and temperature, very important for the advancement of understanding of science and physics, and consequently the barometer is a very, very important measurement tool that has been developed over the years. So that is a look at how you can use hydrostatics to be able to measure atmospheric pressure.